Hello, good afternoon everyone, and welcome to the third instalment of the Big Data London Modern Data Architecture webinar series. Today we're dealing with data visualization. So I'm Andy Steed, a Content Director of Big Data London, and I'm joined today by Mike Ferguson and Kieran Doyle.
Hi all.
Yeah, so I mentioned it's part 3 of 3 today. So parts 1 and 2 are available to watch on demand if anybody missed them. That's on data warehousing and data integration. You can either see them in the attachments part of this screen, it's in the bottom left-hand corner, or at bigdatalondon.com/webinars. The beauty, obviously, of being live on the webinar like now is that these are designed to be interactive, so please send in as many questions as you have, and I'll endeavour to ask as many as I can once the guys have finished presenting. However, without further ado, I'd like to welcome on our first speaker. Take it away, Mike.
Okay, thanks a lot, Andy. So good morning, good afternoon, or good evening, everyone, wherever you may be. Thanks for taking time out of your schedule to come along to this webinar. I'm just going to share my screen here so that I can get my slides up. And there we go. All right, so I want to talk to you obviously about data visualization today, and I've got a couple of things I wanted to say just to link back to the first 2 webinars in the series to start with, and then I'll go into the visualization side around particularly business intelligence and analytics. So I want to look at the current data landscape, the kind of top trends around business intelligence and visualization, what the priorities are there, how some of those concerns can be addressed around trusted data, and then how you can really start to get productive and more effective using data visualization going forward. Okay, so obviously this shouldn't be no surprise. This is just a classic kind of data warehouse architecture that's been around for probably 25, 30 years or something like that. Nothing particularly new there, except to say that data visualization, has been, tools of some sort have been connecting to data warehouses for a number of years. Of course, over the years, those data visualization tools have advanced dramatically, incorporating things like mobile devices and whatnot over that period of time. Except the data that goes into data warehouses has changed dramatically in the last several years. We're not just dealing anymore with master data and transaction data, which would form the dimensions and facts. We've now got demand to analyze other kinds of data, such as machine-generated data like clickstream to perhaps tell you what's going on your website and online behavior there. It could also be sensor data associated with either industrial IoT, perhaps to understand the efficiency of your production lines if you're a manufacturer, or perhaps the your oil fields if you're an oil and gas or organization. It's just 2 examples there. It could also be consumer IoT, such as things like smart watches, smartphones, any other kinds of wearables that you may have some kind of sensor data in that you collect data from that as well. And then there's human-generated data. People's opinions are changing all the time, and if there's any trends and things associated with that, then clearly want to pick those up, whether those are things like social network opinions or whether they're inbound email coming in that way. And of course, external data now rapidly in demand, especially from open government websites. An example of which, of course, is the COVID-19 data now being made available by governments all over the world. So as I said in the last 2 webinars, we've ended up with a kind of ecosystem beyond data warehousing with all this data, not just a data warehousing system to analyze it, but other analytical data stores doing various things from data science activities into training and building machine learning models, analyzing streaming data, doing graph analytics for various fraud and cybercrime examples, just to give you 2 use cases, as well as the traditional data warehousing stuff. going on. And of course, all of this is available on the cloud today, or for most of us, I guess, we're probably dealing in a hybrid situation where some of these systems are on the cloud, some of them not. And so from a visualization standpoint, that often means that with the kind of multiple systems out there, that business analysts are increasingly having to connect to this hybrid computing environment, to different kinds of analytical data stores, whether they be on premises in your data center or one on multiple clouds. Could be cloud data warehouses. You may have on-premises data warehouses as well. You might have big data systems sitting on the cloud, or streaming data coming into the cloud, or all of which may want to be accessed by business analysts to produce certain kinds of reports and analyses. So if you like, self-service data preparation has become the norm as a result of that. And but with regards to business intelligence itself, as opposed to just the data, there's some really key success factors coming out of organizations now. Clearly, they want trusted data, and I think master data has been, by that I mean customers and products and assets and employees, suppliers, those kinds of things, have really been, high quality master data has been very, very high priority in BI for a number of years now. Also, a real desire to shorten the time to value, to really deliver insights that you can act on. So again, any way in which to do that that's going to help is going to be welcome. So if there's ready-made trusted data that you can pick up and use, rather than have to go back to raw data and prepare it, it would be great. If there's simplifying access to multiple data sources so that users don't struggle to pull that data together, if it's all already integrated, that they could potentially use. Get some kind of governance around self-service data preparation so everybody doesn't reinvent the wheel, and perhaps doing it on trusted data rather than always going back to raw data. So maybe some subset of that trusted data that's ready-made could be used. I think component-based development is a big deal now, I think, to rapidly build components in use in business intelligence and in analytics and visualization, in order to be able to share those so that we can reuse them and allow people to produce what they need to build much more rapidly. And automation, of course, through the introduction of AI moving into business intelligence tools. In addition to that, looking at much more effective visual analysis. So ways to help you understand the impact of what the visualizations are telling you, what's the impact on the business, so that you can kind of interpret that and translate that, if you like, for business people to act on. Having actionable BI, in other words, that is to say, really pinpoints what the action should be, maybe even recommends what the action should be going forward. And again, artificial intelligence going into these kind of visualization tools will help with that in order to provide those kinds of recommendations. And of course, a broad measuring stick for the success of BI has always been how many users are using it. And so can you broaden the adoption to empower more users to make use of factual insights in their everyday jobs? And looking at the Fourth Industrial Revolution survey, this is a survey done every year at Big Data London, and I built the full report of this, the cover page of which you can see on the screen here. What's interesting about this is that we asked in November last year 500 companies, what are the skills that are preventing them achieving their business goals? And the number one business skill that came out, as you can see by quite a distance, was data visualization. So this is really now a top skill that businesses are seeking, and companies that can do that. But you also notice change management's high on that list, and also the ability to interpret and to understand the business impact of what these insights are telling them, so that you can act on it and be able to do that in a timely manner rather than being too late in order to take those kinds of actions. So real high priority being given on the visualization side, but also the interpretation of it. So on the one side, we see a desire to want to govern and get trusted data that which we can build visualizations upon, which is very, very important. And at the same time, we're trying to be more effective. We're trying to be more agile. We're trying to shorten the time to value. It's almost like, well, give me the freedom to do that. But at the same time, we want to do governance. And it's almost like they're opposing forces. But actually, we want a way to do all of it. And hopefully this series of webinars has helped you understand some of the ways in which that can be achieved. Certainly enabling trusted data. We spoke in the last webinar in this series about this chart, the idea about ingesting data into a data lake, organizing the data lake into zones, and using ELT processing to be able to produce trusted assets that can be consumed into data warehouses on the cloud, for example, into other kinds of analytical data stores, or even opened up to data science, in which case we can then use visualization tools to start analyzing the data that are stored in these different analytical data stores. But with regards to visualization, certainly the key things that are happening here are people want to be more productive. They want to be able to shorten the time to build those reports, to build those dashboards, to really improve the effectiveness of it, to almost guide users to doing the right thing, to make the right kind of decision. So a whole bunch of new requirements here. I already mentioned component-based development in self-service BI. I mean, that's becoming pretty key because we're trying to stop people reinventing and be able to have reusable components that they can pick up and use, that shortens the time to value, allows you to be more productive in building what you need to build. We're trying to integrate BI tools with information catalogs for two reasons. One is to find the data you need quickly in order to be able to start analyzing it using a catalog. The second reason is if you produce these reports and dashboards and other visualizations, you want to publish those so that other people know they exist and put those in the catalog. So it's a win-win in both on the development side and also in the publishing side. We want to be able to leverage AI in BI tools to try and improve both the user experience, help them be more productive, and perhaps even take action more quickly in order to give you a competitive advantage or to prevent something becoming bad before it's too late. So kind of things that are important with AI, that could be the tool guiding the user to do the right thing, tool automating certain tasks to make it much easier for the users to produce what they need to produce. Also invoking predictive analytics to be able to sort of see into the future rather than always just looking at historical data, and prescriptive analytics to be able to not only predict what's going to happen, but to recommend and tell you what to do about it, which is trying to guide you to do the right thing to be able to achieve overall business goals and improve those business outcomes. And of course, as well, given the number of data sources we already mentioned, trying to simplify access to all of those data sources, again, to make it easier for business users going forward. On the component-based delivery side, there's all kinds of reusable components you could build in BI. Reusable data connections to data sources, views of your data warehouse, get you quickly up and running and just take that view and start working with it. Data preparation services, perhaps other people have invented, you could pick up and just reuse again, so you don't have to reinvent them. Pre-built analyses that maybe others have picked up. Visualizations that I'm showing here as an example on a looker screen that you could potentially build. Even actions, that you could build, so that again, it almost becomes an assembly of these assets that we're trying to produce with visualization tools, not just always start from scratch again. And it could even be combination of these that we could pick up and use as a quick start mechanism going forward. All of that facilitates sharing. It facilitates consistency across the enterprise if we can do that more rapidly. The other aspect of improving BI is really to leverage AI and advanced analytics. And so, I kind of see these two worlds coming together, starting to connect to multiple data sources. So it's not just purely BI, but we've got analytics in there, AI driven, if you like, connectivity to the catalog, as you can see there. And if necessary, to hide multiple data stores, maybe we could even introduce data virtualization as a way to simplify access to multiple data stores to help people become more productive. But if I look at AI, the kind of so-called augmented analytics, that we see that term a lot now, the ability to use artificial intelligence to simplify a user interface, to assist the user during data preparation, to assist the user building in reports and dashboards so they can do it more rapidly, to help them with certain kinds of analysis that they're doing, to perhaps automatically alert them, to maybe even make automatic visualizations based on the context of what they're doing, to recommend the kinds of visualizations and analysis that they should do next in the context of what they're doing. All of these, even automatic forecasting and things like that going forward. And also using artificial intelligence to simplify the user interface, to change from sitting down and having to master a user interface at a laptop or a desktop to just voice user interface, so that you could speak to the BI server, have it translated into a query and get an answer back. That's done through AI. Similarly, again, chatbot, a kind of natural language user interface to simplify that. That means less skills to use the BI tools. You can just open it up and ask questions. An example of course, the sponsor today is Looker's integration with Slack. And so you get this conversational kind of sort of collaborative natural language processing being used in the context of conversations, so that you can access intelligence and get an answer and use it in the context of collaborations throughout your organization. Very easy to kind of use that kind of thing. What we meant by understanding the impact is, well, what happens if you could use artificial intelligence to take a visualization and interpret it automatically and then generate text to explain the business impact, so that people don't miss something that could be hidden in a visualization. Make sure that they do see it, so that they can then potentially act on it, and we can explain the business impact in an easy to understand way. Also, AI in self-service data preparation could help recommend new data sources, could help recommend or automate data profiling, so that you don't have to figure out the quality. The software does it for you. Could recommend or guide you to do the right transformations in order to prepare the data, that could automatically detect anomalies, even automatically correct certain things in taking that, if you like, stress away from the business users, so they become more productive. All of these kinds of activities just make it more guided, make it an easier user experience, and shorten the time to value at the same time. And it can go way beyond that. I mean, I think we're now seeing artificial intelligence really boosting self-service BI by helping to accelerate all kinds of things, providing recommendations on visualization, automatically generating visualizations, automatically detecting outliers, automatically recommending key performance indicators, automatically ranking things. There's all kinds of stuff that you could potentially do here on the back of AI going into BI tools. And of course, we want to go further than just AI in the software. What about all the machine learning models that are built by data science in your organization? How do we use that in the context of BI tools and data warehousing that we've been speaking about over this series? And a good example of that will be, well, what about using self-service BI tools to help data scientists to develop machine learning models? That's one angle. Well, that can be done in two ways. You could either just connect your BI server to your data warehouse on the left-hand side of your screen here, and then you could, with APIs on your BI server, you could invite data science tools like Jupyter Notebooks or a workbench such as Amazon SageMaker here to connect to your BI server, and therefore use the BI server to query the data that's needed to train a model in your notebook or in your data science workbench. Equally, if you're trying to connect to multiple data stores on the right-hand side, you could do that individually, connect to all of them, or you could go through a a virtual view on a data virtualization server to simplify that, and then help pull together the data from multiple systems to train these models. The other side of that, of course, is, well, what about, I think is an even bigger issue, which is once you've built a machine learning model, then what? Can I deploy that and then use it from self-service BI tools? I mean, that would be really cool. And there's a couple of ways in which you could do that potentially. You could take code into your BI tool and then bring the data into your BI tool and then do the analysis there. It's kind of relatively lightweight, if you like, machine learning, if you like, and predictive analytics. Maybe you could do clustering or something like that on data done that way. An alternative approach is that data scientists go off and build these machine learning models, and then they deploy them into your data warehouse, into your Snowflake, for example, or into a streaming analytical environment, or into a Spark environment running on cloud storage like GCP or something like that. And then what? So, well, here, we would like to exploit those kind of models inside BI tools. So here, if you're looking at a forecast, for example, to get predictions onto the visualizations within the context of what you're doing, you could invoke server-side machine learning models that are stored in your warehouse or stored in whatever the back-end analytical system is, so that you then analyze the data close to where it is, because the bigger the data gets, as we said in the last webinar within this series, you want these models to run close to the data. You don't want to pull all the data out into the front-end tools. You want the models to run close to the data and then give me my prediction or my recommendation back that I can then include in the context of the visualizations that I'm looking at on my screen. Of course, we could kind of run them slightly offline and push the results into a front-end data visualization tool. That's also potentially possible. But we want to do both of those things. And we also want to extend, if you like, self-service BI to take on board more advanced visualizations that are associated with some of these new kinds of analytics that we're seeing within organizations today. So the one I've chosen here is graph analysis. So you could see here a chord chart on the left, or a kind of network graph, if you like, on the right, both of which taken either from Looker or a partner of Looker, who are our sponsors on this webinar today. But these are now being incorporated into BI tools to allow you to do that as well. And for as real time is concerned, again, looking back over the series, we talked about how we could use scalable in-flight data integration, bring data in from real-time data sources into a data lake, and then be able to access it through a cloud data warehouse, for example, and therefore be able to visualize real-time data, both from a business intelligence perspective and even data scientists having access to that. All of that potentially possible. So I guess to sort of start to sum up a little bit, we're seeing artificial intelligence playing an increasing part in helping business intelligence become more effective in the enterprise. It's helping to simplify the user interface that broadens the reach of the BI tools across the enterprise, perhaps to less skilled individuals rather than just more skilled business analysts, and gets over the problem that companies have, as we saw. Visualization is a skill that people are struggling to get hold of, those kind of skills. In addition, we're seeing it to help improve productivity and speed up what you're doing in the development of visualizations or in preparing data. We're seeing the ability to even take automatic decision making on the back of the data, so that you could drive recommendations or you could drive alerts that can be done on historical data or streaming data, and it can be implemented by BI tools acting on predictions coming out of server-side models and that kind of thing. So again, looking at something like Looker, we could, for example, have a Looker action, which could then feed maybe data into a front end marketing capability like Segment, for example, in order to be able to do more precision marketing on clustered data that was clustered using a machine learning model. So to conclude then, I think, digital transformation is really driving up the demand for new data. So we're going way beyond the kind of master data and the transaction data that we're just seeing in data warehousing. Typically, we're seeing a lot more complex data, semi-structured JSON, for example, also coming into data warehouses, real-time data wanting to come into data warehouses. The landscape's become much more complicated with all this new data. There's data in multiple data stores sitting in different clouds all out at the edge or in the data center. And BI users want trusted data. So we've got to be able to reach to those sources, be able to pull the data together quickly and get high quality data for visualization. I mean, we all know about the phrase garbage in, garbage out. We don't want that. And it's not surprising that you see trusted data very, very high priority within BI circles today. So getting that ready-made data that they can access, allowing business intelligence users to find that data quickly through a catalog, understand what it means through a glossary, and have ready-made data available that they can move forward with quickly, makes data preparation really easy because I'm starting with a trusted base. In addition to that, things like data virtualization will simplify access to multiple data sources. And then component-based delivery in BI allows you to build these artifacts that can be then almost assembled to speed up the delivery of visualizations and reports and dashboards that need to be shared in a collaborative environment around your enterprise. And by changing the user experience and simplifying and improving productivity using AI, all of that's going to really make a difference to help guide users and broaden the number of users towing on the same rope to meet the business goals that you're trying to achieve. So I hope that's given you some guidance. And I guess with that, I'd just like to say thanks and hand you back over to Andy and Kieran.
Hi, Mike.
All right, let me just stop that. There we go.
Hi, Mike. Yeah. Thank you very much for that. Just before I ask a couple of questions, I was just going to make everybody aware of the fact that these sessions actually become available online as on demand almost instantly after they've finished, to be honest. So if there's anything that you'd like to go over again in Mike's presentation, or have a look at the slides with some of the commentary, you'll be able to do that and forward to the relevant bits and watch again, etc. Obviously, same with Kieran after he's done it. I'm keen to get Kieran on reasonably soon, so I'm just going to do a couple of questions for Mike at this point, and then we'll do more extended questions at the end. However, the first one coming through is about component-based development in BI. There was a slide on that, wasn't there? How do you see it evolving? Does it just apply to BI?
Okay, I think this is a big trend. We're starting to see component-based development happening right across the board. It's not just in BI. Absolutely not. We're seeing component-based data modeling going on, for example. We're seeing component-based pipelines to build data preparation, to integrate data going on. We're seeing component-based configuration for your data warehouse happening. We're seeing component-based visualizations and all of that happening, for example, here with Looker and Looker ML. So, and I think one of the other things that's going on is starting to see the integration of multiple tools with what I would call enterprise version management, rather than every tool having their own versions, have a single way of doing that. And it seems that GitHub is rapidly becoming that mechanism, and so we're starting to see all of these tools integrating with GitHub. And so what this opens up to me is this whole data ops, AI ops, everything ops, ML ops. I've heard of all of these things going on at the moment, and this continuous integration, continuous delivery approach. so that ultimately you build up these reusable assets, and then it almost becomes an assembly process rather than constant building from scratch again and again. And so the implication here is we are going here. We absolutely are going here. And I think that the challenge for most of us is to be able to get an organizational structure in place that brings together the right people to build those components so that we can bring them together and assemble them rapidly, speed up testing, even automate testing when you make any changes to these kind of things, so that you can move forward much more rapidly going, rather than the older ways of doing things.
And just the one more, what do you see as the big differences between information catalog and a traditional semantic layer?
Okay, well, traditional semantic layer is specific to a BI tool. I mean, a data catalog or an information catalog, a data catalog will let you know about all the data that's out there in multiple disparate systems. It could also let you know what trusted data is available that's been published in there. And I think going forward, these catalogs are going to let you know about all kinds of what I would call artifacts or assets, what reports you've got available in multiple BI tools, what dashboards you've got available, what machine learning models you've got available, all of these, what predictions, what decisions are available as a service, which is a prescriptive model, gives you a recommendation back, for example. You want all of these published in a catalog so that it allows people to quickly find what they're looking for. Maybe they find all of what they need, or 90% of what they need is already made, so they don't have to start from zero again every time. So I think it's much broader what a catalog is compared to a semantic layer.
Perfect, thank you, and thank you for the questions.
Okay.
We'll come to some more towards the end, but I'd like to bring Kieran on at this point. So over to you, Kieran.
Great, thanks, Andy, and thanks, Mike. That was super interesting. So hopefully I can kind of build upon what you were talking about there. So let me just bring up my slides. So yeah, my name is Kieran Doyle. I'm a sales engineering team lead here at Looker. So maybe just a little bit of background on Looker itself. We're a Californian-based company that started in about 2012. So 8 years ago, and since that time, we've kind of rapidly grown up until the start of this year, where we had about 800 employees globally across America, Europe, and APAC, and just coming up on about 2,000 customers. At the beginning of this year, then we were acquired by Google into Google Cloud for $2.6 billion, which was really just a great vote of confidence for us in terms of what we were doing with the product. I myself, I've been with Looker for just over 2.5 years now, and I guess for today's presentation we'll be talking about data visualization, but more in the context of data visualization within a modern data architecture. So hopefully we can really focus on not just the visual, because I think that very much scratches the surface, sort of like what Mike just spoke about. How do we actually go beyond just visualizations and actually leverage all of the investment that's been put into the rest of the stack? So hopefully you've been able to see the previous 2 parts of this series, and I highly recommend going and watching those if you didn't get a chance to. But the first part was just setting up good data pipelines using brilliant tools such as Fivetran to set up consistent pipelines into a centralized data warehousing solution such as Snowflake. And really now this part is just to kind of talk about how do we bring value to the business after going through that effort. So to do that, really we're going to just spend a couple of minutes going through Looker's differentiation on how we take an approach to analytics, and that focus will be solely based on the architecture itself, and then hopefully we'll have time to actually go into a live product demo as well and give you a kind of a sense of what Looker look and feel is like. So Looker versus other BI, I guess when you go out into the BI marketplace, and you might have noticed this if you go to any of our websites, and Looker is no different. It's very hard to distinguish between a lot of BI tools in the market. Every tool pretty much promises the same thing. Every tool is wanting to be able to give the ability to explore large data sets in a self-service way. They're all going to be able to kind of offer a lot of different features and functions for business users then to go and explore that data and make more data-driven decisions. And they also want to be able to make those decisions on something that's very reliable and consistent. And so having good governance across the different metrics and reports that are actually delivered. Mike kind of touched on it in his presentation. This is often a very tricky thing to balance. How do you basically offer self-service analytics whilst retaining good data governance and good practices in terms of the metrics that we're delivering? And a lot of products fall on either side of that scale. So like if you look back, in the BI market in the last kind of 20, 30 years, initial players, for that first wave of BI tools that came into play, often provided very, very good levels and standards of reports with highly governed metrics that the business could trust. And that was brilliant because people were able to understand that any data that they were pulling out of these tools were reliable and consistent. But it sort of led to what we typically hear from our customers when they come to Looker in terms of the first problem that they see in this concept of a data bottleneck, where you might have a data-driven workforce that want to be able to ask new questions of data, want to be able to make data-driven decisions, but ultimately are unable to do so because they're sort of tied to the technical team and they can't really ask their own questions. So that sort of paved the way to the second wave of BI, as we would call it. So, introducing kind of more data exploration type tools where, you could rely on that technical team to maybe provide you an extract or a data mart or a cube of data, where you would be able to self-serve, whether you're in the BI team or business user, and you could ask, new questions of the data, you'd be able to get those answered, you'd be able to define metrics. But that sort of tips to that other end of the scale. And, the second problem that we often hear from our customers when they come to us is that they have this notion of data chaos where, people might have access to the data, but they'd be going into meetings and everybody has a slightly different definition of the truth, across the business. So really, you can probably attribute these two problems down to sort of the architecture that BI tools are built upon. So if we look at sort of a modern data architecture, as was discussed in the previous two parts of this series, a lot of tools that when they were created, they weren't built with this architecture in mind. And they were developed in a time when databases were very slow and very expensive. And that's just not really the case anymore. I mean, data warehousing is relatively cost efficient at the moment and incredibly powerful. So for tools in the market at the time, they were often built to compensate for poor data warehousing performance, and would ultimately rely on extracting data from your different data warehouses or from different data sources into data marts or data cubes, and then that data would physically live within the BI tool itself. And from there, the BI tool would leverage its own proprietary infrastructure to deliver analytics to the business. And you can very easily see, I suppose, the problem that arises, or those two problems from this architectural setup. When we're creating a new data mart or view of the data for each use case we have, as that scales out, we often lose control and governance over the logic that we're putting into these different data marts. So, I might take an extract of the data itself, and for a particular use case, I'm going to, define some KPIs and calculations on this extract and push it into a report. But if we do that over and over again, as time goes on, we're no longer retaining that consistent view, so leading to that data chaos issue. And then the second thing is we're still having an element of a data bottleneck here as well. So because we're dealing with the extract, we're no longer looking at a complete view of the picture of the data in the business. If I'm looking at an aggregated part of this data and I have a new question from my report, if that aggregation doesn't capture the new question that I have, I still have to go back to that technical team or go back to my data warehouse or my data sources to retrieve further information. So really, when you're comparing different BI tools on the market, it makes sense to compare them if they're architected the same, if they're traditionally architected on that extraction base. But really what we're talking about with Looker is architecting it differently. And we want you to use the best in breed parts of the data stack. And it sort of addresses a question that came through there from Mike before this. Is it best to get a one-stop shop solution that can do all of this, or kind of componentize your stack? And really, that's the approach that Looker's taken. We are not using our own proprietary data warehousing or servers to deliver analytics. We're able to leverage the investment that you've already made into incredibly powerful warehouses such as Snowflake. So when we do that, and we have that complete view of all of the data that's sitting within our data warehouse, this is really where we want to leave the data. We don't want to over-engineer it past this point. We moved all of our different data sources in here. We've got it at a transactional level. And now instead of physically materializing data out of this transactional level data warehouse, what we want to do is we want to put in a virtual model on top of it. So what is it that the technical team define or do to sort of join up all of these different data sources instead of physically doing it? What are the different transformations within these data sources that do our technical team make? And also, what are the KPIs that we're actually defining on top of the different data? And that's all done through a semantic modeling layer called LookML that sits within the Looker platform. And this really is a code base that enables your technical part of your organization and analysts to define the database in a language that kind of makes sense for the end user. So really converting that SQL that a database speaks into the language of our business. So the output, before we can go to the output, like really the tools that we give those technical people to do this is a code base. That code base is integrated with Git, natively with GitHub, but you can use Bitbucket or GitLab. So you're getting industry standard version control across that and collaboration. All of the metrics are only going to be defined in one location as opposed to dispersed across the business. And then you're obviously going to be able to set up all of your permission management and security from there. And we are 100% cloud as well, so easy to deploy and lightweight. But the main thing is the data retains with you. So we are not pulling data out of your systems into Looker. And the way that this is represented for end users is through a graphical interface where a non-technical person will be able to communicate with this database. When they do that, Looker is going to write SQL on behalf of that end user to the same standard that their technical team would, and return them the results. So really, when we speak about data visualization, like I said, that's sort of just scratching the surface. Now that we've given the opportunity for everybody in the business to ask any question they want of all of the data, visualization really is just one option for delivering that. So I can go and create, pretty dashboards and pretty visualizations. But now I'm not relying on the technical team to do that. I can actually go and build my own dashboards off of all of the data. But taking that a step further, really what we want to start thinking about, now that we're able to build our own reports or ask new questions of existing reports, our technical teams are freed up to start integrating data into other sources. So people aren't the only consumers of data in businesses. Other applications, are also data hungry. So take, for example, I'm a marketing analyst and I've got a couple of marketing campaigns running in Marketo. What I want to be able to do is judge based off of maybe other data, such as web event data, that's seeing how much traffic is being generated from these campaigns. I want to be able to put a KPI on that to understand, what campaigns are actually running well. And instead of me constantly checking dashboards to see, okay, well, are these campaigns doing okay? I know that I'm simply, once I see a campaign underperforming, I'm simply just going to go to Marketo. So why not automate that workflow? And it's those kind of integrations that our technical team can now focus on. So, instead of waiting to see something happen, maybe we're going to get Looker as a tool to automatically integrate with the Marketo API to disable a poor performing campaign. And simultaneously send me a list of all the campaigns we've disabled for the day via Slack. So really kind of automating that into the business. And the final part of this is we often have a lot of our customers building completely custom applications with Looker. So so whether that be leveraging our Python SDK to pull into data science workflows, because we no longer have to do any data munging, or about 40% of our business is made up of our customers embedding analytics into their own platforms for their customers. So kind of endless possibilities there. So I guess in summary, the picture that we're painting is that everyone wants to do self-service BI. Unfortunately, that only works if we can retain a high level of governance. And the semantic modeling layer within Looker is what it gives us the ability to do that. And we can do that on incredibly large data sets by leveraging best-in-breed technologies such as Snowflake to kind of live in database. So jumping quickly just into probably what's going to be one of the quickest demos I've ever given of Looker, but hopefully it'll give you a rough idea of what the product is like. The product is split into sort of 3 core areas. So we've got sort of our browse, explore, and then some technical admin and development areas. So really, as a completely web-based application, there's no sort of desktop install that you have to do. We'd simply just connect to your database via JDBC connection. And your technical team are going to start now modeling out that database and converting it into a language that makes sense. The front end of what that looks like then, so once the technical team have sort of described that database, it's going to be presented to end users in what we call an explore. So this really can be seen as sort of different windows into that database, and where I'm going to be able to ask brand new questions that maybe have never been asked before. Any of those questions I want to save or kind of put onto a dashboard will then be stored in the browse section. So let's actually just start off with a dashboard, because just to completely contradict myself, but just because this is obviously the entry point for a lot of people into analytics, and we can kind of touch on, I suppose, some of the benefits of setting up on an in-database architecture from here. So first off, really living in database and being a live connect to your data warehouse means that all of the data that we're looking at here can be as real time as your technical team is going to allow. So we're not relying on any intermediate layers of extraction. We can get right down to all of the orders that were made this year, right up until this very second. The second thing is that like we talked about, all of the different metrics that we have in here are going to be defined in one location. So say we're looking at repeat purchase rate for this e-commerce data set. This could be living on 50, 100 different dashboards, and that's okay because it's defined in one location. If that definition ever had to change for database reasons or business reasons, the technical team will be able to make a change to that definition in one location, test out that change through the Git version controlled environment, and then roll it out to the rest of the business, in which case all 100 reports will update simultaneously. So no more version 1, version 2 of this dashboard. Everything is being kind of governed from one central location. Daily view, splitting out by category. I'm not limited by any level of extraction either. So I can always drill down into a lower level of detail. Like I want to go into a particular hour of this day, but more importantly, for a specific hour, I want to actually see that transactional level detail that's sitting within our database. And this is really important to be able to get down to that level. People don't make decisions based off of a pie chart. They want to be able to sort of see an area of data where something's going well or going wrong and get an extraction from it. At this level, we're now able to sort of integrate. So like Mike was discussing, integrating workflows into here. So like, whether that's connecting up to your Slack so that I can send a message to our operations team when I see something going wrong, updating an order in Salesforce, rather than having to jump out into my Salesforce application, I might want to have to just change this dollar value from Looker itself. Emailing out customers, quite trivial examples, I think, in some ways, but more done in practice, I suppose, is these would be alert-based mechanisms that would just sort of let people know through various channels when something happens within the data. But of course, we can always just keep on asking new questions. I can drill across to this particular customer, to a different dashboard, being browser-based, it's just very easy to sort of navigate around here. Arguably at this point, I suppose, this is all still looking quite similar to other products. You're still getting visuals. These visuals are probably still being made by your technical team or your analysts. So what happens when we've got a new question? How does Looker differentiate itself by not having to go back to that technical team? So say I'm looking at average order value, and this is great. I can see it as a single value for the last 90 days for this particular customer. But I have a new question, and I don't want to have to go back to a technical team to ask it. Well, at every point within Looker, we're going to have this option to jump down through the platform and get down to this data at a database level. So we're now moving into our Explore section. And really, just to give you a little bit of context to wrap up here, this is the core of what Looker does. So instead of technical teams focusing on building dashboards, like for example, looking at orders, items, and users in my business, and assuming that I'm going to just know the 20 or 30 questions that people are going to ask and slapping 20 or 30 answers onto one static report, what we're actually wanting our technical teams to do is take a step back from that data warehouse that the rest of the technical stack have done a great job to centralize. Take a look at all of the different data points that we're actually collecting in that warehouse. That could be of interest to someone asking questions around orders, items, and users. And basically tell the system how do these different data sources relate to each other. So I might have my order items coming from my proprietary database, my production database, for example, and I might also have my users information that's coming from my CRM system. And we're basically telling Looker, how do we typically join this together, not physically going and joining it. And what that allows our end users to do is to make use of some of the logic that our technical team can impart here. So they're going to do the transformations, they're going to make this very readable for business users, and they're going to put all of the KPIs in here so business users can actually go and ask me questions. So in this drag and drop environment, I can now ask a brand new question like the total gross margin for the last 90 days or so for this particular customer. I can hit the run button. Basically what's happening in the background here is Looker is generating SQL on the fly that our technical team would have written, but now they don't have to. It's firing that SQL to the data warehouse, it's getting us an answer, and then we can visualize that answer. And now we can keep on going with that method. I can keep on asking new questions. Like now I want to see that particular metric broken out for the last 90 days by date. Again, Looker is going to go and write that SQL on the fly for us. We're going to be able to run that data back to the warehouse in real time, get the results, and then visualize those results the way that I want. So really, visualization, don't be fooled by it. It is by far the easiest part of any BI tool's job. Getting the data to feed the visualization is the tricky part. And that's the piece that we really want to sort of make use of. And it really just opens up the possibility for people being able to ask any question they want, find out something about that question, and then continue asking more questions. I want to now break this particular KPI out by a different demographic, such as age tier. I want to go and visualize that. And I'm still going to be able to make use of all those features and functions that we saw on the dashboards, because all of those dashboards you've seen so far were actually built using this interface. So I'm still going to be able to drill into that. I'm still going to be able to now even explore this subset of data a little bit more. And finally, I guess now that we've given access for everybody in the business to ask any question they want of all of the data within a safe and governed environment, really it means that now we can start again focusing on those other integrations. So it's not just about putting this visual onto a dashboard to come back to later, and we can share this data in many, many different ways. So even if I just ping over the URL to a colleague, they'll be brought to the exact filters and visualization options that I've picked. I could have of course save it to a dashboard, but I could also download the data into Excel or CSVs or do whatever I want from there. I can go and I can send this data. So really tie it back to other business workflows that we have. So maybe I'm that marketing analyst, I'm sending it to my marketing campaigns. So I don't want to have to download these email addresses and manually upload them back into Marketo. I want to simply say, okay, these particular users, I want to add to a new campaign that I've got, and just allow me to do that integration directly from Looker. So hopefully that's given you a rough idea of what we mean by, not just relying on the visualization. Really, Looker works close to the database and wants to give business users all of the power of those technical folk that live, in your company, and I guess just enable a bit more, data-driven questions to be asked in a more flexible way and not be inhibited by sort of having to go back to a technical team all of the time. So like I said, that was a very quick sort of whistle-stop tour of the product itself. Just in terms of additional resources, I do want to just put in a plug here. We have our annual data conference that is running throughout May and June. You can register for that. It starts tomorrow at looker.com/beacon-EMEA. And I promise you there'll be far more interesting speakers than I talking at that. We'll also try and answer some questions today, but we'll be reaching out to everybody that's registered as well. So do feel free to get in touch, go through our website. And yeah, thanks very much.
Yes, so both presenters mentioned the previous two webinars in this series. And for anybody who didn't hear me mention, you can access both of those on demand. It's in the attachments section at the bottom left-hand corner of your screen. Also in there is a link to Beacon that Kieran just mentioned. So if you want to find out a little bit more about Looker's event Beacon, do check it out in the attachments as well. We've had some more questions through. I think we've still got a little bit of time for some questions. If I could, I'll start with you, Mike, seeing as we haven't heard from you for a little bit. It says there's other types of analytical front-end tools, graph analysis tools, stream analytics. How do these relate to BI? Is that?
Yeah, I kind of think what's happening there is historically we've seen for different kinds of analytical data stores, different kinds of visualization tools. Graph analysis would be a good example, but I think from what I showed in my presentation, the trend here, as far as I can see, is that self-service BI is growing to incorporate other kinds of analysis and visualizations as part of the that tool. And so I guess the trend, is towards a single products trying to do that. Of course, that also means that if the backend database is not relational, then such as a graph database, then there would be a need to either translate a SQL statement into some kind of graph query or support the graph language natively. But I mean, generally speaking, I think it's pretty clear that the extensive visualizations that have been added to BI tools by both vendors like Looker or even through bring your own visualization kind of idea, now with things like JavaScript and whatnot, you can extend these tools to be able to kind of handle these kind of more complex visualizations on more complex kind of data going forward. So I don't see these as being. I think the trend is towards self-service BI broadening its visualizations and analysis to be able to handle different kinds of data going forward.
Okay, thank you. And I'll move to one or two of the raft of Looker-based questions we've got. Just so you know, your questions will be answered. If I don't come to them, someone will come back to you. But starting with does Looker have an in-memory caching to reduce load on the database?
Yep, absolutely. So yeah, like that caching. If reports say don't update within the data warehouse, more than once a day or once an hour, you'll be able to configure caching so that you're not going back to that server every single time. And that caching can be extended out to 30 days, at which point it's purged.
Cool. Can Looker support multi-tenant scenarios if we want to embed analytics into SaaS products?
Yeah, for sure. Both multi-tenant and single-tenant scenarios. So you'd be able to do row-level security and embed. It's embedding is one of the biggest products that we have. Like I said, it makes up about 40% of our business. So handling row-level security within a multi-tenant scenario works very well. Also, if you've got a separate database per customer, as long as that database is roughly schematically the same, we can parameterize the connection to the database as well. So handling that single-tenant setup too.
Okay. One last one for you then, Kieran, before we return to Mike. Yes. How long does it take to build the LookML, and how does the database need for this to be carried out? How clean does the database need for this to be carried out? Sorry, the jumble question.
Yeah, that's a good question. I guess that really depends on the database structure and the use case. Typically, we offer trials to our customers or prospects, like free trials, and they typically last 2 to 3 weeks. And my main job is, I suppose, working with those prospects to help build out 1 or 2 use cases. So from my experience, I mean, really within the first week, you're enabled on LookML, and you're able to ask, comfortably build on your own. The second week, you're pretty much nearly there with the first use case in terms of delivering reports. Generally even on the first call, we'll have some sort of report built. But yeah, as long as you know SQL and you know the questions that your business is asking, it's a very, very quick process. After that, it just depends on complexity in the database itself. One last note on that is just we do a lot of transformation within the Looker layer. You can also rapidly prototype your ETL process in Looker, so we can write new tables back from Looker into your data warehousing as well.
Perfect. Thank you. So I think one last one for you, Mike, and I think we're probably going to have to bid adieu, unfortunately. My question: in the current trend of BI, we're working so fast and agile data changing environment. Building a data warehouse is very long and complicated. What's your advice? Is it to use a small tabular model analysis or some other modeling technique to represent the business more quickly and speedily and accurately?
Wow. I think if your data warehouse is taking very long to build and complicated, then clearly, improving agility in data warehousing is a huge amount that can be done for that. I mean, one is reducing the number of data stores in your overall architecture. I think Kieran mentioned kind of virtual views as opposed to data marts, and therefore getting rid of that, which makes changes quicker. In addition, I kind of think also there are enterprise data warehouse modeling techniques to make change really quick. Data Vault would be a good example of that. So I kind of think that there are significant ways in which to improve productivity and agility in data warehousing without sort of saying, well, we don't need a data warehouse going forward. Of course, obviously, it's a very simple problem. You can take this whole thing and move to a kind of, I suppose, a standalone data mart kind of approach. But you can't have a lot of those before things start to break down and you end up with a lot of inconsistencies going across multiple different data stores. So for me, I would be looking to try and significantly improve the agility of your warehouse before just ditching the idea of warehousing and saying, let's go after a totally different approach.
Perfect. And like I said, unfortunately, I think time has got the better of us once again. I'd just like to say thank you for great presentations from Mike and Kieran, and thank you to the other presenters in the other webinars in this series. Like I said, if you haven't seen them yet, do go and check them out. And for the last time with the data architecture series, we're going to say goodbye. So thank you very much, and I hope you enjoyed it, and goodbye. Thank you.
Thank you.